All right, let's go and get started. Thanks for showing up this morning. I really appreciate it. And hopefully this will be kind of a fun little thing. This is just a fun little module that I made one day. It just came up after just a discussion in a Discord. And it was just like, I wonder if I can do that. And so I went in and I looked and I did it. So that's what we're going to talk about today. So this is going to be TaskJob, which is managing any .NET task and managing it with a PowerShell job. So a little bit about me. I'm Justin Grote. I'm a data center solutions architect, a Microsoft MVP. These are my links here. Anybody? Yeah, I thought maybe I would just pause for a minute for anybody who's in my previous presentation. You'll get the joke. If you weren't, then you're going to have to go back and watch on the video in 6 months, and you'll get this joke in 6 months. So enjoy. First and foremost, I'd like to thank Ally Digital, my employer, for sponsoring my travel to be here and taking very good care of me. We do all kinds of data center transformations, all that kind of stuff. Like our job is taking over IT departments when people don't want to run them. Your job is in your company, you have your core competencies, your applications that matter for your business. That's what makes you different from anybody else, and that's how you make the money. You don't hire, you don't run your own electricity, you don't run your own sewer, you don't run your own plumbing, you don't do your own trash. You hire people to do those things so that you can focus on what you do best. And so we take over the infrastructure part of things so that and take care of that so that you can focus on what you do best. So great company. I worked for them for about 15 years. Check them out if you're in the market. Also, big thank you to the sponsors for making this happen and buying me drinks very irresponsibly last night, so to make this presentation even better. All right, and that's it for the slides, because we're going to go all demos today. Ta-da! All right, so before I get too far into this, let me just get off here. First thing I'm going to do is I'm going to just take a survey real quick. We're just going to go light and dark so you can get an eyeball. And then, so who likes the light more? Who likes the dark more? Oh, man. I'm going to go with the light just for, yeah, all right, yeah. I'll do this for you poor people who have, yes. We are a representative democracy, and we're here for you poor little guys, so we'll go this direction. All right. So in the .NET framework, excuse me, not in the .NET framework, let me start over. So one thing that when we're doing things, who has ever used a PowerShell job or a thread job or the command for each parallel before? Awesome, great. So for those of you who haven't, these are just ways to basically like background tasks. And the main reason you would want to do this is if you have a script, if you've ever written a script where, like, say, a really common example would be like you need to get some users, and for each one of those users, you need to change something. So you do this in Active Directory, you do this in Exchange, etc. Excuse me. And you need to go through and you need to do those things. So you need to do 1, you need to do 2. You know, that's fine. It goes, the script kind of completes pretty quick. Maybe you need to do 10. Okay, it's a little bit longer. Then you move up into big company X. And they're like, oh, this is a great script. Can you do this against 3,500 people? And I'm like, yeah. And so you go to run the script, and you're sitting there, and you realize this script is going to take like 3 days to run. And you're like, uh-oh. So how can I make this thing faster? Well, let's see. Could I break it up into batches and run the script on 4 different computers or 4 different terminals? Yeah, but that's really hard to manage. Is there any other way I can speed this up? Well, what's really slowing me down here? Well, what's slowing me down is I'm making these calls out to whatever, and I'm waiting for it to come back. Is there a way that maybe I can just have something that would parallelize out these things so that they would all make calls, but they're not waiting, it's not, stepping and waiting on the next thing to go. How can I like fan this stuff out so that they all go and then they all come back at the same time and save myself a lot of time? So when you start asking yourself those questions of your scripts, that's when you start getting involved with things like jobs and run spaces and threads and for each parallel, which makes all this stuff really easy. So that's just a preamble for the way that all that stuff works is this system in PowerShell called the job subsystem. So PowerShell, as I always like to say, like PowerShell is just a .NET application written in C# and a couple other things. But in the end, it's just a .NET application. Like we all love to treat it like it's the holy grail of everything. But in the end, it's just a C# application. So as a result, you can do anything in .NET, you can do that in PowerShell. And that's extremely powerful. So because PowerShell, by its nature, the way that it was written is single-threaded for a good reason because of the way that it's interactive. It doesn't play well with some of the newer technologies that sort of came along after the initial idea of PowerShell came out. And one of those is .NET tasks. The idea of a .NET task is very similar to a job. It's a much more stripped down, like it doesn't have all the same kind of scaffolding as like what you would think of a job. A task is a very simple thing that is basically just a promise of a future state. That's kind of the, I'm not gonna get too much into like the really technical nitty gritty of what a task is because it took me probably 9 months to even get the basics through my head, and I'm not gonna do that in 5 minutes. But all you really need to know about a task is that it's sort of a structure around anything in C#. And so as a result, it's built to be extremely general so it can handle all cases. And all it basically is a way to say, I am giving you a promise. I'm just going to give you something that's a promise that you will get this result back sometime in the future. And so what that just allows you to do, like that's the very framework, but that allows us to have jobs because that means we can say, hey, I want you to go get this thing, but I don't want to wait for you to come back. So instead, if you send somebody, you need to send out runners to go, get you coffee in the morning. You don't let them run, and then you stand there staring at the door. I mean, you probably do, depending on how hungover you are, but you don't just stand there staring at the door waiting for them to come back. You send them out to go do that thing, then you're off working on something else, and like he promised, all right, I'll be back, when I have your coffee. But that still frees you up to do whatever you're doing. And then at the moment that guy comes back and he's got your coffee, you're like, oh, okay, great, and now you can process coffee. And so that's the whole idea behind jobs and asynchronous programming and all that kind of stuff. There's a great if you go to the .NET information, there's a great, they do a really great analogy with cooking breakfast in terms of like, you don't just make the eggs, wait for them to be done, and then move on to do the bacon. You can start the bacon, start the eggs, put in the toast, and then when you hear the ding on the toast, you go and handle the toast and you do that. That analogy is what really made it click for me about how all the task type stuff works. So with that preamble, even so, in PowerShell, because of the way that this PowerShell is authored, working with tasks is a little difficult. And more importantly, working with what are called asynchronous methods in .NET. So if you just do day-to-day PowerShell, if you're just doing command lists and that kind of stuff, you're doing get, set, etc., you're never going to see any of this stuff. And so you don't need to worry about it. But once you start getting into more and more things, you start realizing how powerful PowerShell is, and you start wanting to use it in more and more places. And so sometimes you'll come across something, and you'll come across something and nobody's written anything in PowerShell for it, but somebody's written something in .NET. Like if you go out to NuGet.org and you just search, like, here's a simple example. It's like, I love ChatGPT. Like, I think it's amazing. It has vastly improved my work. I wrote a module using Copilot based on a breakfast conversation today. It's out there. It's a new module, a new credential manager module that's going to be a secret management vault. I wrote it in 45 minutes because I found a library that wrapped all the really complicated C# stuff of the credential manager and just had some simple methods, and then just wrote the functions, but all the ChatGPT stuff filled in a lot of the boilerplate for me, and then I just said, no, that doesn't work, you're a liar. But it still saved me a ton of time. And so one of the things I did is when I was building this module called PowerShell Assistant was that it had a way to auto-generate. There was I think there was a presentation on auto-generating modules from like Swagger files and Open API, I think yesterday. Gary's, yeah. So if you see that one, you'll see I have a module that does all that generation. I'm not going to show it too much. I'm not going to show any of that here today. But the point is just simply the APIs that thing generates are all asynchronous, because asynchronous APIs are great because they're not blocking. And what that means is, just like I said, you're not standing here waiting for the guy to come back with your coffee and doing nothing in the meantime. An asynchronous API gives you that ability, just like a job, if you're familiar with it, to basically be given a promise that something's going to be done later and allow you to go off and do other things, and then when that's done, come back and grab it. So we all know how jobs work. Or if you use jobs, you're familiar with the general flow of just like get job, remove job, receive job, all that kind of stuff. So if you've worked with jobs a bit and now you're getting into this thing like, oh, there's this thing that has like a .NET framework thing, and like if I get these libraries, I don't have to write all this crazy. Somebody already figured out how to work with that API, or somebody already figured out how to connect to ServiceNow, and I don't have to write directly against the REST API. I just have to call their methods, and they give me back these really nice objects that then I can do the stuff that I want to do with. But then most of the time when you get into these, a place you'll get stuck is you'll get to a place like, okay, this method, ChatGPT has create completion async, where you say, okay, I want to get a completion. I want to say, what's the best cookie in the world, and have whatever it comes back with. But as soon as I call that method, I get an instant result back, and it's this thing that has this weird look to it, and it's a .NET task. So I'll show that here in a little bit about what that looks like, but you'll get this thing back, you're like, what is this? What am I supposed to do with this? And if you don't know anything about these, then you're just stuck. You're like, okay, well, I guess I can't use this API. So eventually later you kind of learn that, oh, there's this thing I can do called .getAwaiter.getResult. And I have no idea what that means. I have no idea what that does, but it seems to just work, so I'm going to do it. And that's just a complicated way of basically making it so that basically turning that async method into waiting for the guy for coffee and standing there waiting for him to come back. But then you're kind of again, if you need to fetch all kinds of things, then you're stuck in that same problem you had with the 3,500 users, where your script is slow because it's what's called I/O bound. You're waiting for the output and the input to come back. So if you get stuck in that situation, then how can you sort of solve that thing? Well, you can learn all about. You can be a maniac like I am and spend 3 months just learning how asynchronous programming works in general, just to solve one problem. So yeah, feel free if you want to do that. Or you can be like, oh, I already know how like PowerShell tasks work. I'm familiar with that concept. Is there anything out there that can really help me and take care of that? So that's kind of like why I wrote this module. So it came up in this all came up in a conversation in Discord where somebody was like, hey, I got this API. It has like these .NET tasks. And we're all telling them about like the get await or get result. And the guy just looks at me. He looks at me through the text. You can see the text as it comes in that he's just like glazed over eyes. You can feel it through the keyboard about all the get await or get await stuff and like how to do things like task wait all and wait any because he needed it to be parallel and stuff. And he's like, can I do this with PowerShell jobs? I'm like, yeah, you can. Like you could do this and you got to do all this stuff and it'll work. And it was this really complicated code. And it started making me thinking. I was like, is there any way like we could just make tasks .NET tasks, or make .NET tasks just like a job? Yeah. Steven? I mean, there's a certain spoiler going on here. Yeah, you will, because good. Then you get. I don't know about that, but I do know what one of my favorite threats is in my company. Oh yeah. Oh no! Oh, my computer died. Oh, I'm sorry. This presentation's over. Thanks so much, guys. I really appreciate you coming out. All right, yeah. I'm sorry. Could you please repeat the question so I can repeat it for the recording? The question is, does the get a waiter have a get a check? And the answer is no. I'm not answering that question. Yes. Caused a Justin doesn't care exception thrown. With now I'm really thrown off. Like, do this to me after I haven't been out, like with Matthias. How dare you? Okay, so let's get down here. So with this module, this is not a super complex module. So this is in C#. Like if you've never seen C# before, I know it's curly braces and brackets and all that kind of stuff and boilerplate to the end of the earth, and you have no idea what's going on. That's fine. I barely understand what's going on in here half the time anyways too. But the important thing down here is one thing that you can do in C# if you don't know about it is basically the whole idea of like classes and objects and blah, 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 blah. They're just these things basically that are kind of act as what are called interfaces. And the idea is that if you've ever made like code and then like you were like, oh, I need to like, this was working with this, now I need to make it work here, now I got to rewrite the whole thing. It's like, what if we could instead like establish a contract where we could say, hey, if I'm working with you and we're all working together, my program is just going to expect that you are going to have, a particular property and you're going to have a particular method and you're going to have these things. But I don't care like how you do it. I don't care how you do it. I just want to know that like, almost like, like a government office, I can fill you out a form and I don't care whether Steve handles it or Frank handles it. Maybe they do it in different ways, but ultimately the way that I hand it off gets done. That's sort of like a brief analogy of what an interface is. And so in PowerShell, there's actually an interface for PowerShell jobs. And we should be able to do this. It doesn't break on me. Yes, it's mad at me extension, but we'll fix that. And so in here, we get this thing. So basically what this is what an interface looks like. And again, don't freak out. Like, this is all C# crap. Don't worry about it. It's not going to matter for when we get there. But the point of this is, as you can see, it's just what I'm saying, is that, the definition of when you want to make a job, this interface makes it so that, it's not like a full implementation. It just says, hey, you can actually supply your own ones. And a big important thing here is it says it's public. That means that the PowerShell team has marked this in a way that says, hey, if you want to make your own job provider, you can. All you got to do is basically fill in this boilerplate. Like think of this like you had a function and the function had all the parameters defined, but it didn't have a body. So that somebody gives you a function and they say, if you use this function, my script's going to call your function. I'm expecting you to have a name parameter. I expect you to have a path parameter. I expect it to have these things. And if you have all those things in there, then I'm just going to call your function and then whatever you do is great. I'll accept your result. And that's basically what this is. This says that, hey, if you implement these properties, if you make it so that, hey, if you give me some kind of function that resumes a job, so like When I'm ready to resume a job, I'm just going to call this thing, and you do whatever it is you need to do to resume your little job. Resume job async, don't worry about that, but like start job, stop job, you get the idea. The idea here is that they provide a contract, just like giving you like a function with a bunch of parameters that, hey, if you implement this thing, we'll accept it, and we'll treat it like it's a PowerShell job in the user interface. So what I do is I simply just take this thing and I implement it. So this colon here just says, hey, I'm going to make this new class called TaskJob, and it's going to implement job 2. And that's what that colon means. And then I just go down here, and every one of those things that they asked me to implement, I put in here, and then now I have an actual implementation of how it works. And it's really not that complicated. I mean, it looks complicated, I get it. But really, basically, this just comes down to, hey, when you pass me like a .NET task, I'm just going to take that thing, I'm going to build a new job, I'm going to take the task you gave me and wait on it, and then I'm going to get the result of that task, add it to the output, and then tell the job that now this job is completed. Like, this is the core of the code. The rest of this is just scaffolding to make the job happy. But basically, this is just a glorified me doing get await or get result. But because it's in this thing and doing it in a way that, because I'm doing it in C#, it can use the whole C#, what's called asynchronous programming interface, so that it can do the whole thing rather than wait for the guy to come back for coffee. It can, okay, let this thing go off and do a thing, and now, but I'm not going to block the PowerShell thing. You can keep doing what you were doing. And then when you're ready to come back, when you're ready to check on this job, you can do your get job, and I'll be able to see, like, is this job done yet? If it's not done yet, if it's still processing, it'll say, like, in progress or whatever. But then once it's completed, it'll hit there, and then it'll show up as complete. So this preamble is just the idea of, to give you an idea of how this was implemented. And the main reason I'm showing this is just to show that, like, this is just something that I just saw in the PowerShell code. And I was like, oh, you can just implement this. And honestly, like, I could have actually probably used a PowerShell class to do this. It's just again, the asynchronous stuff and the way that that works and the way stuff blocks, it wouldn't have been as good. But there's all these kind of little things that you can implement. So let's get into where the rubber hits the road. So now we get to my favorite part of the presentation. One of my favorite threats at work is like, don't make me mad or I'll replace you with a script. Well, Steven made me mad, so I decided to replace him with a script. So we got a few different things here. I broke this into functions because I always feel like it's really good to kind of break down what you're doing so that when you get to the very important task, that is your high-level task, which is remove Steven, then it's really easy to follow. It's easy for anybody, even Steven, to follow what's going on. So the first thing we're going to do is we're going to get some joke tasks. And I just use the HTTP client as a simple example of something that, like, if you go online, like, one of the first examples they always do for like async tasks is using this interface, or they use like file read all bytes. So this is effectively, when you do invoke REST method, or if you do invoke web request, there's a ton of scaffolding, but when you eventually it gets all the way down and it basically does this exact same thing, is that it comes out, it gets itself an HTTP client. We set our URL, which I just found some joke API, made sure to get the pun, and then blacklist, a bunch of stuff I probably don't want showing up in the recording. And then what we're going to do is just do a simple loop is for 1 to 10. So for each of these objects, $client get string async. And get string async, this is our async method, that if you call that, you're not going to get jokes back. You're going to get tasks. And like I said, you're going to get receipts. You're going to get promises. You're going to get the guy saying, all right, I'm going to go get that coffee joke and then come back and bring it to you. You do whatever you want in the meantime, but when I come back, I'll have it and you can deal with it then. So that's the core of what that does. So then typically, this is where, like, if you're doing normal code, this is where you'd probably do like the for each, get await or get result, or you do like task wait all or wait any or any of that kind of stuff. And if you've never seen any of that kind of stuff, it's all very C-sharpy. It's all .NET tasks and commands being run in PowerShell. And it's really ugly, especially if you're on like a team. But rather than have all that extra scaffolding there, now you can just do this. You just say, you can, with this new joke jobs, I just take whatever I pass to this and convert it to TaskJob. Oh, by the way, little side note, filter keywords. Has everybody seen the filter keyword before, aware of it? Oh man, you're in for a treat. You guys are today's lucky 10,000. This is excellent. So all this filter keyword does, it's just a function, but rather than the default block being the end block, the default block is the process block. That's it. Like literally, if you go to the code in the PowerShell implementation, that's all it is. But it's a really nice little syntactic sugar kind of a thing where what I would have had to do otherwise, I would have had to do function, jobs, I would have had to do thing, value by pipeline, et cetera, and make it so that this can be processed by the pipeline. By making I can have this really terse thing instead that simply says filter new jobs, whatever comes in on the pipeline, do whatever I do in that process block. So this is, I'm a big fan of getting rid of scaffolding as much as I can, because I want again, programming is for humans. Otherwise, we'd all write an assembler. Programming is not for computers. Programming is for humans to interpret things, to talk to computers. So if it's complicated and it's very hard to follow, it's very hard to maintain, it's all that kind of stuff. Anybody, even like your business owner who's just like reviewing your code to get an idea of this, they can look at this and have a pretty good idea about what's going on. And so it cuts out all that boilerplate. You have to see process, you have to figure out what process is. So I like filter because it's no different than function, process, bracket, etc. But it cuts out the things and lets you make these just really nice pipelinable things very easy. And so what that does then, we can get down to our main function here. And so I really like the new PowerShell 7 style. If you didn't know this, in PowerShell 7, you can put the pipe on the new line. And so you get these very nice, how easy is this to read about like what's going on with this function? So first thing we're going to do is we're going to get our joke tasks and then turn them into jobs, which is our new functionality. And so now we'll have those jobs ready to go, and then we can hop through those. And then all of this, if you didn't see that I was doing the .NET task type stuff, the rest of this is just as if you were working with regular PowerShell jobs. So I can receive the jobs and wait on them. I want to wait for whatever I fanned out because I went out and requested for 10 things. We're going to convert to JSON. We're going to do, you know what? How about we just do it and see what happens? So let me get my extension terminal back up and hope it doesn't get mad at me again. And I'll show you something that if you didn't know you could do this, check this out. You can make a terminal one of your editors. And you can tab it over here and all that stuff. So we can bring this all the way over here. And now you can have it up there instead of the bottom. This was a change about a year ago. It's been around for a little while, but it's kind of neat because it's really good for presentations, and you can do the old Zen mode thing. Now you got this really easy, clean view of what's going on. So we can take our script, Alt-enter that in, clear things out. And so we'll start out at first. We'll just do get joke tasks. So you do that, and this is what you would see. These are .NET tasks in sort of a nice little format. It's like, okay, what do I do with these? It's like, what is all this? how do I use any of this stuff? Like, I don't want to go become a C# programmer to work with any of this kind of stuff. So basically, .NET tasks are complicated because they're very abstracted. They're designed to be like you can do almost anything with them. But as a result, you get this very obtuse language to describe them that it doesn't feel very practical. So what we can do now is we can just take these, and we have the filter for new joke jobs. So I'm just going to take this little part of this out. And what this will do is this just takes those jobs as they got created. And now instead of those, I have my familiar PowerShell jobs with a name and a little thing. And by the way, you can assign custom names to these. So if I do that again, well, I can't do it with the parameter there. But anyhow, like when you do the convert to TaskJob here, there's some additional things you can do. Like you can assign a name to them. So like if you're doing a bunch of different things at once, you can group them by name so that you can come back. And it'll provide you to the object. So ideally, you're not like going back and doing get job to get them. That since this returns the objects, you should set them to a variable so that you can just track them where you're at. This is just typical job stuff. This isn't anything special to .NET tasks, so that you can track where those go. So now that we got that, we got those jobs and they go out, and let's go ahead and run what I've been looking forward to all morning. Except I don't want to screw up my script already. Remove Steven. So what the script did is it goes out, gets 10 things from this joke API, and then presents them in a thing. So pick your favorite dad joke here. What do you call a witch at a beach? A sandwich. And my favorite part is like, these are amateur level. But we really don't need much more than that, Stephen. It's good enough. I kind of like this one. I walked into a bar once, it really hurt my head. So we'll take that one, and we'll go back to our VS Code session, and here we have a nice little right host. And there you go. So, but the interesting thing there was, you noticed like when I ran that script, it went out and it fanned out 10 requests to go get all those different dad jokes, because it's just making, this API, while it does support like getting a bunch of jokes at once, this is just a contrived example. This is like if you had an API that was like, you can only call it once. Well, you don't want to call it and then wait for the joke and then call it and then wait for the next joke and then call it and then wait for the next joke. So the 1 through 10, I said, hey, just run this command 10 times. And so basically I sent 10 people to go out and get jokes. And they're like, great. And they all run off and I can do my thing. But rather than wait for the first one to come back and then ask the guy to go to get the next one, they all come back at once. So if I were to run this script without doing them as jobs, if I can change it, actually I don't think there is just a get string on this. But if I were to do this as like just get string, it would have taken like probably easily like 20 times longer. So and this comes down to the same thing of like you're doing the job for like do 3,500 people, you can do this for that. So if you have something that doesn't have a PowerShell interface for it, but it has a .NET API, or you can make a .NET API for it, as long as it returns tasks. And that's what's great about this interface is basically if it returns a task, and typically the convention is that they don't have to be this way, but if the function ends in async, usually that means that it's going to return a task. But that's just a naming convention. Like anything can return a task. And so as long as your method returns tasks, you can take advantage of this way of doing the same kind of parallel that you're used to for like for each parallel, all those different kinds of things that come through, and really kind of speed up your scripts, but take advantage of those libraries. Somebody's already done all the work. With the PowerShell community, we're all about building on each other and working on what we have. We're all, at least in my opinion, we're all just lazy engineers at heart. We just want to get stuff done. We just want to have something that's going to get things completed. And if somebody else has done the work that has made that for me so that I can save time, so I can provide more value to my company, I can be more valuable, and I can get things done faster, then I'm all for it and I'm here for it. So this is just another tool to start leveraging that kind of stuff, where the .NET ecosystem is massive. There's so much stuff out there. And a lot of it is perfectly accessible to PowerShell, except that it's in .NET libraries. And it's just the way for PowerShell to use .NET stuff is just really obtuse. So I wanted to build a tool like this that makes it so that the concepts that we're familiar with, jobs, et cetera, thankfully the PowerShell team, in their infinite wisdom, made this interface. But it's just something that like maybe someday somebody would implement anything, but they didn't. So I showed the detail also about how to do the task jobs in terms of like how I implemented it. Because you saw it was just simply a matter of this, I just had to provide the methods of what it does. So this job could, you can make a task job provider that just intercepts everything that comes through and replaces it with a dad joke. So I'm giving you a challenge here, Stephen. So that any .NET test, no matter what they do, no matter what they call, they're expecting to get back, their array of financial information, and it just comes back as a spreadsheet of dad jokes every time. They're like, what's going on? It's because they're using the provider. And again, it's just a contract. It just says, I will tell you when I start job, and then you do whatever with that. And when I say receive job, you're just going to give me whatever you prefer. So that's both very powerful and very dangerous. So be careful. So you can review the code of mine, get that. But if it just installs as a PowerShell module, it's out on the gallery. But if you just go after that, let's do GMO thread task job rather. It's just implemented as a module, a binary module there. So it's just a binary module. In fact, in this case, like it doesn't even have a PSM1 file because I wrote the actual convert to commandlet in the C# level, just because it made more sense in the context. Otherwise, I totally would have written it in PowerShell. But it's just a PowerShell module you can fetch. It's full of bugs. I mean, like this doesn't work in a lot of corner cases. But the idea here is that you can see how you can utilize a lot more of the .NET framework. You're not just locked into hoping somebody makes something for PowerShell. Like if you can get a .NET library for it, even if it has tasks that you don't understand, now you can convert them to jobs in an ecosystem that you understand, and you know how to receive jobs, wait jobs, maybe do some stuff, work on the jobs once at a time, and if one job fails, handle it, and then come back to the other ones, retry it. But work with that familiar style of jobs that you're used to and anything. So that's my presentation. This is all about TaskJob, and I hope you guys learned something, and I'm going to go ahead and open the floor for questions, and thank you. Yeah. What are the odds? For the camera, Stephen has a question. So, yeah.
Where did you find that job to? How did you find that in the PowerShell so that it would then, it's exposed, but how did you know to go look for it?
So here's how I did that. Let's do a new job. New job. oh my God, I'm going to fail this hard. By the way, part of it was, so I found it one of two ways. The short answer is that if you look at the ThreadJob module, I was like, how do ThreadJobs? Because ThreadJobs use run spaces instead of processes. And I'm like, how can you just use getJob and receiveJob with those all the same? And I went into that module and I saw that it was it basically just had, gotta get back to my, get out of Zen mode here. It had, basically it was like ThreadJob, job 2, like implemented job 2. Again, because VS Code is so wonderful and I'm gonna evangelize it and all that kind of stuff, I just had to do go to definition, and it has this header out of the PowerShell module that told me where that was. And I'm like, what's job 2? And I thought it was something in ThreadJob. I'm like, oh, that comes from PowerShell. And I was like, and normally when I do this kind of stuff, like I'm investigating it, I come up and it says sealed. And I'm like, all right, well, that's a non-starter. What sealed means is that, oh, you could do it, but we're not going to support it, and it's going to throw an error, and you got to do all kinds of crazy reflection stuff to hack this stuff into PowerShell. Pretty much, you almost have to fork PowerShell to make it work. I think the best way to put this, like, again, this is all C-sharpy stuff that like I'm not good at, and I'm sure if Patrick was in this room, he would just be like over there, just like, no, that's not how it works. But basically, when it says if it says sealed instead of public, well, not public, sorry. If there's a sealed in here, it just simply means that you can't derive from it. So like it's saying like, hey, we have this job 2, we can derive, and not sealed, like it's internal sealed. That means, in our own code base in PowerShell, we can make our own derivations of that. So we can implement that contract, but we're not going to let you implement that contract. Like if you're going to make a module or something, if you try to implement this contract, it's just going to throw an error. The compiler is going to throw an error. And so by default, like basically, quote unquote, you can't implement the interface. But of course, we're all in computers and we know there's always a way. And you can use reflection and all kinds of stuff to actually get in there and hack it in. But first of all, like that's not nice. Second of all, it's clearly unsupported. It's like the PowerShell team's not going to help you. Like, yeah, you implemented a private interface. Like we made it private for a reason because it's an implementation detail. And we never meant for anybody to do that because we don't want to support whatever you built for 10 years and get your stupid tickets in our issues repo, and just go away. I don't care what you're trying to do. I'm not bitter though. But in this particular case, this is one where they said, hey, this is something where like if you build something that implements this interface, we'll support it. Like we'll make sure at least that when you do the start job, if something in the way that we call the start job stuff works, if something that breaks, we'll support it. Like we'll get it fixed for you, et cetera, for the lifetime of the program. It's just sort of it's an explicit contract. It's a way of in programming enforcing saying, hey, you can implement this stuff, you can't implement this stuff. So I can show you my source code, but I'm not going to let you get into these parts. Like if they made certain things about PowerShell public, like if everything was public, like I could probably have you import a module that the second you type a command, it steals all the credentials out of your Windows Credential Manager and sends them to me. So that's the reason why they don't make everything public, obviously, because PowerShell is very security-centric. But this is the thing where, again, I implement this and you do my jobs and you create jobs. You have to create jobs using my commands, so that means we're a good steward and code reviewed my code, right? Didn't just use it. So the point there is just simply that, yeah, it's here as a public contract, and so I found it through the ThreadJob module. And then if you go into the GitHub of PowerShell, I should be, and you hit period here, which I'm sure you've all seen, where you can get a nice little editor. Then I just searched for job 2, and then I could see, oh, this is how it actually works, and that kind of stuff. And then I promptly got confused and cried and drank a lot, and then came back. I was like, oh, I just have to implement the interface. I don't have to know how all that stuff works, and that's the beauty of interfaces. So there's the typical Justin answer to your 2-second question. It was in ThreadJob. I think I saw a question over here. Not Yop. No, he's on my list now. Yes, Yop. Guest speaker, Yop Brosser, everybody. The question was like, so with a filter, because a lot of people haven't seen this syntax. I know this is kind of, when you see this, it's like, what would this look like if it was a function? It would look like this. Actually, I'll just rewrite it. Like you can make this a refactor. Function. There you go. That's the same thing. literally in the code that is the same thing. It's almost like an alias. Like there's no magic happening. That's what it looks like. Because typically a function, it's never, if you leave, you probably, as you remember, we have like begin, process, and end. This stuff's all explicit. Like if you want to explicitly say like how a function works, you put all these in every one of your commands. Basically, a typical function looks like this. A filter looks like this. That's the only difference. It's just a nice little syntactic shorthand. But I use them a lot. Like one of my favorite things to build with them are just like, but as you saw, like once I made that function, that little short thing becomes this really easy pipelinable thing where just like whatever comes down the pipe shows up as PS item and you process it that way. So
I think that maybe what might be missing is that if you write it as a function, it jumps to the end. So when you're typing in, it'll only do the last.
it'll only do the last one, yeah. So unless whatever you're doing knows how to handle an array or whatever, yeah, it'll also only do the last item that came in. So by putting it in the process block, it makes it pipelinable. You can also, these things, you can still add parameters and all that kind of stuff, and you can do value by pipeline by property name. Again, literally the only difference is that it's just the implicit default, if you don't specify all three of these, is process instead of end. So but again, like it's not wizardry. It's literally just a nicer, terser syntax for the same thing. Because I don't want to type function process all the time. When I learned I could just type filter and get these things, oh, it's super nice. Yeah.
So the same class that gets called in here for run spaces.
The job 2, this guy? Yeah. I'm sorry. Go ahead. Finish your question. So the question is with this job 2 class, which this is a very old interface. Were things like posh RS jobs and the old ways of like doing run spaces and all that tricky run space stuff. What did that use this class? And does what I do cut through all that cruft and just get down to like the very bare bones of it? So the two parts of that are for posh RS job, yes, it did use this for in terms of like when you got no, posh RS job did not use it because if you remember, you didn't do receive job in RS job. You did like receive RS job. So he just wrote his own implementation, which is fine. And so that used there's this thing called run space pools and all that kind of stuff, which is outside the scope of this conversation. But basically, it has a very obtuse .NET API if you've never seen it before. And it's very confusing and really easy to introduce bugs. But he just made a thing that made that easy. But he just basically wrapped it as PowerShell functions. So the answer to your question is like, is this stripping all that away? No, this is more like to the side. Because there's sort of three ways you can do parallelization in PowerShell. One is by process. So if you do get job, start job, all that kind of stuff, what you're doing is you're actually starting a whole new VS Code instance. Like it backgrounds, but if you look at your Git process, you'll see there's a whole new PowerShell or PWSH instance that starts up and has to load all the stuff, load all the information, load all the .NET framework to then run your stuff, and then it gets killed. So the reason that run spaces are faster, like the big thing I always say is like you've probably seen a lot of like, hey, run spaces are faster, or for each parallel is faster because it uses run spaces here. Run spaces, run spaces, run spaces. Run spaces is just a concept in PowerShell. It's like an environment that your script runs in, and it's partially that's the part that's like single threaded, and why doing parallel stuff is so hard. That's why we have to make multiple run spaces. But the difference between a process, between a job and a run space, is the run spaces get created in the same PowerShell process. So there's not all that startup cost. There's not a starting a new process, loading all the DLLs, starting the whole .NET environment all over again. It's just simply basically instantiating another class that allows a script block to run. So that's why those are so fast. This is something entirely separate. It still requires a run space. This doesn't use a run space at all. This is down to the raw .NET task, and it just everything basically happens in the CLR. But we'll just say for clarity, it happens in C#. Is that the PowerShell never touches anything. Once I start that task, everything that happens in there is all at the sort of .NET C# level. Like there's no PowerShell script blocky run space stuff happening at all. So it's even lighter. It's super light. So those things. So you can spin up a ton of tasks, and they are all super light. So like a run space you spin up, it's still got to load your modules. You got to load your scaffolding. It's got to initialize the run space. And modern things like for each parallel now will actually like reuse the run spaces, so it's even faster. But it's still a bigger hit. So like if you want to get really, really tight on that performance, when you're using tasks, then the task will do that. And the other thing is that in .NET, tasks have this really nice thing called task chaining, where you can have one task, do another task, do another task, do another task. But the coordinator can do that thing where it's like, all right, I want you to go get that coffee, and then I want you to go get this thing, and I want you to go get that thing, and then report back to me. but I don't have to check in with you each time or stop what I'm doing. I can go off and do other things. Again, this is all the confusing asynchronous stuff that makes performance stuff really nice, but can be very confusing. This is just like another way to do that kind of performance. But at the very base level, tasks are just becoming so ubiquitous because it is such a nice way of doing things quickly that this is just sort of like an easier way to manage tasks for PowerShell people. Does that make sense? Okay. All right, well, I think we'll go ahead and close early. So again, thank you very much again. And of course, all love to Steven. Thank you for being a good sport. These jokes aren't as good as yours, I'll admit. They're not bad, though.
They aren't, are they?
No.